What we want to do is we want to actually evaluate Laplace transforms for piecewise functions now. And so how do we evaluate the Laplace transform for a piecewise function? There are some different ways to do that, but what we're going to use for our purposes right now, as we're just learning about the Laplace transform, is we'll use the definition for the Laplace transform. So let's suppose we have a function of the form f of t equals 1 if t is greater than 0 and less than or equal to 2, and 2 if t is greater than 2. So we want to find the Laplace transform for L of f of t. Well, we know the Laplace transform is going to be the integral from 0 to infinity of e to the negative st f of t dt. However, we actually have a piecewise function. So what we're going to have to do is we're going to have to break up that integral. So our Laplace transform, L of f, is going to end up equaling the integral from 0 to 2 of, and from 0 to 2 our function is 1. So it's going to be e to the negative st times 1, f of t dt, plus, and then we'll integrate from 2 to infinity, and this is going to be 2 f of t dt. Or excuse me, not 2 f of t dt, but 2 e to the negative st dt. Now what we can do is we can go in and integrate each one individually. The first, the integral from 0 to 2 of e to the negative st dt, is going to equal negative 1 over s e to the negative st evaluated from 0 to 2. And that's going to end up equals, and this is going to be negative 1 over s, and this will be then e to the negative 2s minus e to the 0s, negative 0s, which is just negative 1 over s times e to the negative 2s minus 1. So that's the first part. The second part now is going to be this integral here, which is an improper integral. So what we're going to be doing is we're going to take the limit as n goes to infinity of the integral from 2 to t of 2e to the negative st dt. Or excuse me, 2 to n. And so this is going to then be the limit as n goes to infinity of 2 times e, or 2 times negative 1 over s e to the negative st evaluated from 2 to n. I'm going to pull out the 2, and now I'm going to get 2 times the limit as n goes to infinity of, and this will be negative 1 over s e to the negative sn, and then minus 2 times negative 1 over s e to the negative 2s. This is now going to give me 2, and then this limit as n goes to infinity, this is going to get very small, so this is going to go to 0. And so that's going to be 2 times 0 minus 2 times negative 1 over s e to the negative 2s, which in fact is 2 over s e to the negative 2s. Now what we'll do is we'll combine the two. We'll combine this one and we'll combine this one. So we're going to get negative 1 over s e to the negative 2s minus, or plus rather, 1 over s plus 2 over s e to the negative 2s. And then we can combine these two right here, and that will then give me 1 over s e to the negative 2s plus 1 over s. Just a quick note, what I did here is I actually just distributed out the negative 1 over s in order to allow me to combine my like terms. And so that pretty much completes it. That's what we're going to be doing. So what we'll do is we're going to construct an improper integral, okay, for the part of the piecewise function that actually will go to infinity. The other part is just a standard integral utilizing that Laplace transform definition. Let's take a look at another example. All right, let's take a Laplace transform for a piecewise function that's a little bit more tricky. This is that f of t equals sine t when t is between 0 and pi over 2, and t when t is greater than pi over 2. So to find our Laplace transform, what we're going to do is we're going to break this up into two parts, just like we did before. 0 to pi over 2, and that'll be e to the negative st sine of 2t dt. And that's because we're evaluating f of t is sine 2t between 0 and pi over 2. Plus the integral now of pi over 2 to infinity, and so that'll be our improper integral, of te to the negative st dt. We'll do the first part here first. So we're going to take the integral from 0 to pi over 2 e to the negative st sine 2t dt. And that'll end up equaling 1 over s squared plus 4 e to the negative st times sine 2t minus cosine 2t. And we'll evaluate that from 0 to pi over 2. So this is going to give me 1 over s squared plus 4. And so we got e to the negative pi over 2t. And that'll be multiplied by sine of pi minus cosine of pi. So that actually ends up being negative 1. So this is going to be e to the negative pi over 2s. And then we'll subtract from that negative, and then we'll plug in our 0. So e to the 0, sine 0 is 0, cosine 0 is 1. So this is going to be plus 1. And that's our integration. You can go through and do that integration yourself. Now we'll go in and do the improper integral. So we're going to take the limit as n approaches infinity of the integral of pi over 2 up to n of te to the negative st dt. And that's going to end up equaling the limit as big N approaches infinity of negative 1 over s e to the negative st minus 1 over s squared, and this is te to the negative st, minus 1 over s squared e to the negative st. And we'll evaluate that from pi over 2 up to n. What you'll see is that if we plug in the n, this first term, that's going to go to 0. And that's because the e to the negative st is getting bigger than the t. You can go and use L'Hopital's if you really want to look at that. That's up to you. And then in addition to that, this other part here, that's also going to go to infinity. That's going to go to 0. So both are going to go to 0 as n goes to infinity. So the first part here is going to equal 0. And then we're going to subtract from that, and we'll plug in our pi over 2. So we're going to get negative 1 over s times pi over 2 e to the negative pi over 2s minus 1 over s squared e to the negative pi over 2s. We'll bring out the negatives and pull out the negative pi over 2s's. So we get e to the negative pi over 2s times, and this will be pi over 2s minus 1 over s squared. Pi over 2s down on the bottom, minus 1 over s squared. Now all we've got to do is put the two of them together. So we get 1 over s squared plus 4 times e to the negative pi over 2 times s, okay, plus 1, plus e to the negative pi over 2 times s times pi over 2s minus 1 over s squared. Or excuse me, plus. It should be plus 1 over s squared, right? Because we actually changed signs twice. And that's it. Big note here is that when we're going through and we're trying to find the Laplace transform of a piecewise function, is that you're going to break it up into 2 parts, or however many parts you have in the piecewise function, assuming that it in fact is piecewise continuous, right? So make sure that the function is continuous. But if it is, we'll break it up into its parts. One of the parts is going to be a standard integral, probably using integration by parts, and the other part is going to be an improper integral, and you're probably still going to have to integrate by parts. Okay, that's how we go about finding the Laplace transforms for piecewise functions.